Hello everybody, and welcome to another episode of Back to Basics. Today we're going to be having a look at half-wave rectifiers. Now we just finished talking about a bunch of different types of diodes. Now I'm going to start working into what we can actually use these diodes for. And one of the most basic circuits that you can use a diode in is the half-wave rectifier. Now there's not much to do but to go right into this, so I'm going to shift this up just a little bit and we'll talk about how a half-wave rectifier works. So we're going to have a supply voltage here, and it's actually going to be AC current. And then we're going to be coming out of that AC current and we'll run it through a power diode, such as a 1N4007. Good old bog standard diode. And then we'll have a load, in this case just a resistor. Actually, just to appease fanatical, I'll go ahead and make this the European version of a resistor, just like that. And actually for today's demonstration we're going to have a 4.7K resistor right there. Now what happens in a half-wave rectifier? Well, we've got an alternating current signal coming in, right? So if we look at this on an oscilloscope, which I'll actually be demonstrating in a few minutes here, we have the graph here, and our waveform is going to look kind of like that. That's actually probably one of the best sine waves I've ever drawn. But anyway, so alternating current, your current or your voltage, well, it's called alternating current, but your voltage goes positive, then it goes down, and then it goes negative, and then it goes positive, then it goes negative. Now, in the United States, we have our mains voltage set at 117 volts at 60 hertz. So basically what happens is it makes one of these 60 times a second. And this peak here and this peak here is about 117 volts. Most people say 120, but it's actually closer to 117. And in the UK, your voltages tend to be in the 230 volt range at 50 hertz. Now that means that it makes this peak and trough 50 times a second, and each peak is 230 volts. Just like this. Oops, that's a minus 230 volts. Now what does that mean for this circuit? Well, there's my eraser, way over there. So, yeah, let's actually go ahead and get rid of the title, because I need some room to work here. So, let's have a look at what's going to happen on paper here. So, I'm going to redraw my initial sine wave here. So that's what's going in. Well, what's going to come out? Well, we know that diodes only allow the flow of current in one direction. And in this case, well, for conventional current flow, in this case, that's in that direction. So, while the waveform is positive, on this part of the waveform, current is going to be flowing through the circuit, just like it should. Now what happens when the waveform goes negative? Well, in that case, current is wanting to go this way, but it can't because of the diode. So what's going to happen is we're going to get a waveform that looks a little bit like that, because the troughs of the AC waveform aren't going to be allowed to flow through the circuit. Pardon, by the way, the sound of the dishwasher in the background, if you're wondering what that humming noise is. So we're going to go ahead and take away the whiteboard, and I'll grab my nice anti-static mat here, and go ahead and grab a circuit that I built earlier. Now, the next thing I'm going to grab is one of my new favorite tools that I just recently got the remainder of what I needed to use on this channel, and this may actually be somewhat challenging to use on the channel because of glare. Well, let's see what we can do. Maybe it'll show up if I do it like that. So I'm just going to go ahead and plug this in. Now what this little thing is, and I've actually built one on the channel previously, it's an oscilloscope. And I'm going to need to zoom down, I think. There we go. So we'll let the oscilloscope boot up there. And there we have our waveform. There's actually a graph on the screen here, but we're not going to be able to see it very well today because this screen doesn't seem to show very well on the camera, but that's all right. Anyway, so let's go ahead and have a look at the unmodified waveform here. And it would help if I actually turned the supply on. So there we go. We've got a nice, neat sinusoidal, that's what that is called, sinusoidal waveform. Now I'm just going to quickly make some adjustments here to make it a little bit more visually interesting. Alright, there we go. Let's bring... yeah, we'll go with that. Oops, too far. There we go. So now, what I have in here is, we can have a look at it here. It's running at 60 Hertz, and we've got, well, my probe is set to times 10, which means that it's actually dividing the input signal by 10. And so each division here is going to be multiplied by 10. Our volts, peak to peak, is 3.34 volts. Well, that certainly doesn't make sense now, does it? Because I should be getting 12 volts peak to peak, and we're reading 3.34 volts. Don't worry about it. Anyway, so the actual voltages here don't matter. I just wanted the waveform, and I actually had a heck of a time getting this waveform. Turns out that the signal generator I bought doesn't really work. We can get a nice sinusoidal waveform, but we can't actually see the rectified versions of it, and I'm not entirely clear on why it doesn't work. But this one does work, because what I've actually done is I've torn open an old transformer-based power supply and tapped off of the transformer inside it for this voltage, which actually means I'm playing around with mains voltage right now, but I'm only playing around with the low voltage side of the transformer. So let's go ahead and plug this in across our load and have a look at the resultant waveform after we've run it through a diode. Now we're getting a little bit of a trigger issue here. see if we can... There we go. So there, you can see, I've actually got this diode in backwards, so let's just flip that around real quick so that it looks just like what I drew. So there we go. You can actually see the half-wave rectified waveform here, where we've lost the bottom peaks due to the presence of that diode. That's actually a very lovely example of that waveform there. Anyway, that's pretty much it for this video. Just a quick demonstration there about half-wave rectifiers. If I've left anything out or made anything unclear, please start a discussion in the comments below. If you haven't already, consider clicking here to subscribe. Right over here will be a video that YouTube thinks you'll find interesting based on your watch habits. Right over here will be the Back to Basics playlist, and right here will be a link to my Patreon. Patreon subscribers do get these videos 1 week in advance. Also an announcement on this video, I am changing my Back to Basics playlist upload schedule to Mondays, where it used to be on Sunday. So thanks so much for joining me again, and we'll see you next week. Bye-bye.